All right, so now we're starting the calculator portion of the exam review. So there are 17 questions here. I'm going to give you 13 of these 17 altered in some way. You can choose to omit any one of these questions on the exam. So for 19, it says a particle moves along a line so that its velocity is represented by this equation during the time period from 0 to 3. So find the distance traveled during this time. Now, as long as you remember that distance is absolute value, since this is on the calculator portion, you can do this on your calculator if you want to. Now, understand that when you do it on your calculator, the answer might be off a tiny bit with absolute value, so just don't say none of these if your answer is off by a tiny bit. Okay, so let me remind you of how you can get that integral on your calculator. You can either go alpha window, and you can see it there, number 4, or you can go to math and go down to number 9, either one. Okay, so again, that was alpha window and choose number 4, or go to math and choose number 9. All right, so for us, our interval was from 0 to 3, and our equation was x squared minus 5x plus 6, okay? So if this was displacement, that's all that I would need. But distance cannot be negative. So if it's distance, I have to do absolute value. And so to get that, again, I'm going to do alpha window, and it's the very first thing right there. So then I could put my equation in. So one more time, if it is displacement, it's just the plain integration. If it's distance, I have to do absolute value. Now, this is not the exact answer. If you go back and see when we worked it out by hand, 4 and 5/6 is a tiny bit different from that. So again, you can do it on your calculator as long as you don't say the answer is none of these if your answer is a tiny bit different from this. Otherwise, you're going to need to break it into two separate integrals, the positive piece and the negative piece, and do separate integrations, and I don't think you want to do it that way. All right, then for number 20, we have the derivative of cotangent 4x plus 1. So the derivative of cotangent anything is going to be negative cosecant squared of that thing. That would be the derivative of the outside. And then the derivative of the inside, derivative of 4x plus 1, would be 4. So that's negative 4 cosecant squared 4x plus 1. Then 21, we have implicit differentiation. So that means that I'm taking the derivative and the y is inside. I'm not getting the y on the outside by itself. So for implicit differentiation, you're going to take the derivative like normal, but if you take the derivative of y, you have to leave a dy dx in there. So the derivative of x is just 1. That wasn't a y, so I'm good with that. The derivative of y is also just 1, but because that was y, it was not in terms of x, I leave a dy dx in there. Over here I have a product, so I'm going to do first times derivative of second plus second times derivative of first. So first, x times derivative of second, so the derivative of y is 1. That's not in terms of x, so I leave a dy dx in there. Plus second times derivative of first, derivative of x is just 1. So again, you're going to take the derivative like normal, but if you take the derivative of y, you leave a dy dx in there. Now I'm going to get all my dy dx terms on one side and everything else on the other side. So this 1 is going to subtract over here. The negative dy dx stays here. This x dy dx is going to subtract over here, and my y is going to stay here. So all my dy dx terms are on one side and everything else is on the other side. So now let's factor out that dy dx. So if I do that, I'm left with a negative 1 minus x. And so I can divide both sides by that other factor to get dy dx by itself. So that would give me negative 1 plus y over negative 1 minus x. Now, you could leave it that way, or you could factor a negative 1 out of the numerator and denominator and cancel those, and that would give you 1 minus y over 1 plus x. It wouldn't matter which way you wrote it if you were writing the answer, but in multiple choice, just be sure that you don't say none of these if they write it this way, that you understand that this is the same thing. All right, 22, a particle moves according to the law of motion where s is measured in feet and t in seconds. When is the particle moving forward? A particle moves forward when its velocity is positive, it moves backwards when its velocity is negative, and it's at rest when its velocity is equal to 0. So I could ask you any of those things. So for this one, we're going to take our velocity and set it equal to 0 and solve it. So I took out the greatest common factor of 6, and then I just threw this in my quadratic or factored it by hand, whichever you prefer. And I got t is equal to 1/2 and t is equal to 1. So if they had said when is this at rest, 1/2 and 1. Now I'm going to come make a sine graph for my velocity. And so I'm going to plot my 1/2 and my 1, and I'm going to pick a test point, so I chose 0. And if I plug 0 into the velocity, I get a positive 6. So at 0, it's positive. So it's positive right here. Cross a single root, the sign changes. Cross a single root, the sign changes. So that's the sine graph for velocity. So that means that it's moving forward from negative infinity to 1/2, backwards from 1/2 to 1, and forward from 1 to infinity. All right, then for 23, they gave me a related rates problem. So a ladder 10 foot long is leaning against a wall with the foot of the ladder 8 foot away from the wall. If the foot of the ladder is being pulled away from the wall at 3 feet per second, how fast is the top of the ladder sliding down the wall? So I gave myself a drawing here. Here's my 10 foot long ladder, and they told me that it's 8 feet away from the wall. So I'm going to call this distance x, and I'm going to call this distance y. And it says the foot of the ladder is being pulled away from the wall at a rate of 3 feet per second. So this distance down here is changing at a rate of change of 3. So dx dt, rate of change of x, is going to be 3. It says how fast is the top of the ladder sliding down the wall. That would be this distance right here. So the rate of change of that distance would be dy dt. That's what we're trying to find. So now we need an equation that relates those three quantities, and we could use Pythagorean Theorem. So we could say x squared plus y squared is equal to 10 squared. If your value is a constant with related rates, you go ahead and plug it in before you take the derivative. If it is not a constant, if it's a changing quantity, you do the derivative first and then plug it in. The length of that ladder is not changing, so we can go ahead and plug it in before we take the derivative. So the derivative of x squared is going to be 2x dx dt, because again, we're doing implicit differentiation with respect to time, so that means you're going to do the derivative like normal, and then you're going to leave a derivative in terms of time in for every variable. So the derivative of x squared is 2x, and we leave a dx dt in there. The derivative of y squared is 2y, and we leave a dy dt in there. The derivative of 100 is 0. So now let's go back and plug in what we know. They told us that x was equal to 8, and they told us that dx dt was equal to 3. We know we're finding dy dt, but they did not tell me what y was equal to. So there has to be some way in this information over here that I can find y. And sure enough, if I know that this is 10 and this is 8, Pythagorean Theorem would let me find out that y is 6. So we're just going to do x squared plus y squared equals 10 squared. Y squared equals 36, so y is equal to 6. So now I can come over here and put 6 in for y, and my only unknown would be dy dt. So that's going to give me 48 plus 12 dy dt is equal to 0. Subtract 48 from both sides and divide by 12. Now the reason that's negative is because it is a decreasing quantity, or it's getting smaller. So you could say it's sliding down or decreasing at a rate of a positive 4. The negative just shows that it's decreasing. All right, for 24, they ask us to use Newton's method, and you can use your calculator for that. So let's switch back over to our calculator if we could, please. And you are just going to run the program called Newton. So go to Program and choose Newton wherever that is on your calculator. you're going to give it your equation. And so our equation was x cubed minus x squared minus 1. And then it's going to ask you for your starting value, your guess, and they told us to start with 1. And so it will do all the work for us, and it will shoot out our answer. So there's our answer, 1.465571232. So we definitely want to do that one on our calculator and not by hand. All right, then for number 25, they ask us if this is our cost function, then what is the marginal cost? Marginal always means derivative. So if it's marginal cost, marginal profit, marginal revenue, whatever, I just take the derivative. So all we did was just take the derivative here. The derivative of 680 is 0. Derivative of 4x is 4. Derivative of 0.01x squared, we're doing 2 times 0.01, so 0.02. And then we reduce our exponent by 1. So that would be our marginal cost. All right, 26, they ask us, what is the position function of a particle given the acceleration and a few details? All right, if we integrate acceleration, we get velocity because acceleration is the second derivative and velocity is the first derivative. So let's integrate our acceleration. So antiderivative of 5 is 5t, and antiderivative of negative t to the first would be negative t to the second over 2, or negative 1/2 t to the second, plus c. Then they told me for my velocity that v of 0 is equal to 2. That means that if you put 0 in for t in that equation, the answer you get is going to be 2. So if I put 0 right there and 0 right there, I'm going to get c is equal to 2. So if c equals 2, put a 2 right there, and there's our equation for velocity. Now we're going to do the antiderivative once again to go back to the position function. So the position function, the original function, is going to be the antiderivative of velocity. So antiderivative of 5t would be 5t to the second over 2. 1/2 t to the second would be 1/2 t to the third over 3. So 1/2 times 1/3 is 1/6 t to the third. And then the antiderivative of 2 is going to be 2t. And I'm going to use a different variable instead of c. So I'm going to do plus d because if I did c, that would mean that it was positive 2. And d does not have to be positive 2. So they told me that s of 0 was equal to negative 4. So if I put 0 into my function in the place of t, I'm going to get 0 minus 0 plus d. And they told me that when I plug that in, my answer would be negative 4. So that means d equals negative 4. So let's put negative 4 right there. And then that gives us our position function. All right. Then for number 27, they asked us, we have the antiderivative of x squared plus 1 over the square root of x. Now remember, you cannot take an antiderivative of a quotient. There has got to be a way to simplify this so that I don't have a quotient. So I'm going to rewrite the square root of x as x to the 1/2, and then I'm going to break that apart into two separate pieces. So x squared over x to the 1/2 plus 1 over x to the 1/2. So when your bases are the same and you're dividing, you can subtract your exponents. So 2 minus 1/2 would give me 1/2, or 3/2. And then this x to the 1/2 becomes x to the negative 1/2 to move it up to the top. So I haven't taken the antiderivative yet. All that I've done is just simplified. So to take the antiderivative, I'm going to add 1 to 3/2. That would be 5/2. And then divide by 5/2, which is the same thing as multiplying by 2/5. And then here, add 1. So negative 1/2 plus 1 would be 1/2. And dividing by 1/2 is the same thing as multiplying by 2. And then don't forget your plus c. All right, and then our last one, two different ways that you could do this. You could use U-Substitution, or you could break it apart into two separate pieces, whichever you like better. So for this one, if I let my denominator be cosine x, u be cosine x, then the derivative of that would be negative sine x, and the differential du would be negative sine x dx. I don't have a negative sine x dx, I just have a plain sine x dx. So that would be negative du. So now, Sine x dx becomes negative du over u squared. So let's move that u up to the top with a negative exponent. Antiderivative of u to the negative 2 would just be u to the negative 1 over a negative 1. Negative divided by negative would give me positive u to the negative 1 plus c, or 1 over u plus c. U was cosine, so if I back substitute, now I've got 1 over cosine plus c, and 1 over cosine is secant. The other thing I could have done is written this as sine over cosine times 1 over cosine, which is tangent times secant, and we have a formula for that. That is secant x.